Hello, exercise 15.1. Probability exercise 15.1 we are going to discuss. Complete the following statement. First question is fill in the blanks. Probability of an event plus probability of an event not E. That is, we know probability of event and not is equal to 1. That means probability of E plus probability of not is always equal to 1. So this is 1 because the sum of probability of complementary event is equal to 1. This is the explanation. Now, second question. The probability of an event that cannot happen is called impossible event. Such an event is called impossible event. So probability of event that cannot happen is maximum, it is 0. Correct? What is the possibility? Max? It is 0. Such event is called an impossible event. So example, suppose a die is thrown and we have to determine the probability of getting 8. Is it possible? No. This type of event is called impossible event and probability of event is always 0. Third, the probability of an event that is certain to happen is 1. And such event is called a sure event. This is called a sure event. Now, example, if you want to see, this is the example. The event of getting a number less than 7 in a single throw of die is sure event and its probability is 1. Now, fourth, the sum of probability of all the elementary event of an experiment is always 1. So whatever the number of elements is coming in the outcome, if we will add or we can find out the probability of, suppose we are throwing a die, then number, what are the possible number? 1, 2, 3, 4, 5 or 6. If we will add, then maximum it will come 1. Now, the probability of an event greater than or equal to is 0. First is 0 and less than or equal to is 1. The probability of an event always it is greater than, this is the situation, 0. Whatever the element probability, this is equal to 0 or this is equal to 1. This is the range of the probability. Now, next question. Which of the following experiment have equally likely outcome? Equally likely outcome means both the probability is equal. Suppose an event is happening, like a driver attempt to start a car. The car starts or does not start. So what is it is equally likely? Maybe due to some defect. Now first, the car starts normally, but when there is some defect, then car does not start. So outcome are not equally likely. So in this case, the chances are, normally it is here 90% it is opening and it is starting, but due to the some defect, it is not starting. Due to the some, there is just some condition is there. So the outcome is not equally likely. So this is the important explanation. Now, second question, a player attempt to shoot a basketball. She shoots or missed the shot. Okay. Now, suppose the outcome in the situation is not equally likely. The reason behind that is because outcome depend upon many factors such as training of the player, quality of the basketball. These are the things it depends upon. So it is not equally likely. So equally likely, and so just you have to apply little bit common sense. A trial is made to answer a true and false question. So there are only two possibilities. Either it is true or either it is false. So definitely it is equally likely. A baby is born because there is no any other conditions are there. But in the first and second example, there are some conditions are there. So wherever the conditions are there, in that case, it is not equally likely. A baby is born, fourth, boy or girl. So there are only two possibilities, correct? So this is definitely equally likely event. So this both example are equally likely, and this first and second are not equally likely. Now, why is tossing a coin considered to be a fair way of deciding which team should get the ball at the beginning of football game? Now, when we toss a coin, we get either head or tail, which are equally likely outcome. Suppose two teams are playing. So first team wants to take the charge for this bowling, but at the same time, second team also wants the same thing. So in that case, to differentiate the things and in which team what they are going to select at the time, toss is required. So in the toss, because this is unbiased and they are equally likely, so result of the toss of the coin is completely unpredictable or unbiased. So tossing a coin in the fair way of deciding, this is the best way. That's why all the deciding factor depend upon the where the equally likely event is happening. Which of the following cannot be probability of an event? Now, first thing is probability never be negative. So this is not possible. This is 15% is okay because this is fraction 0 to 1. This is also lying between 0 to 1. This is lying between 0 to 1. So this is not possible. So that's why second is not possible. Now question number 5. Probability of an event is 0.05. What is the probability of not? So we know probability of an event plus probability of not is equal to 1. Now this is given 0.05. So here 0.05. So just we have to subtract from 1 minus. So this is probability of an E dash equal to 1. So probability of E dash we can write 1 minus 0.05, that is 0.95. Now next question. A bag contains lemon flavored candy only. Malini takes out one candy without looking into the bag. What is the probability that she takes out an orange flavor candy? Now, the candy, a bag contains lemon flavored candy. So, and Malini takes out one candy without looking the bag. What is the probability? Now, there is no any orange candy. Then what is the probability for getting? That is 0. The lemon flavor candy definitely the bag contains lemon flavor. So probability for getting the lemon flavor is definitely C will get. So this is 1. Now question number 7 we are going to see. It is given that in a group of 3 students, the probability of 2 students not having the same birthday is 0.992. Not means we can write probability of 2 students not having the same birthday is PE dash. What is the probability that 2 students have the same birthday? So PE plus PE dash is equal to 1. So just we have to subtract from 1. We will get the probability of PE dash. Now, a bag contains 3 red balls. So this is the bag contains 3 red ball, 5 black balls. A ball is drawn at random from the bag. What is the probability that the ball drawn is red? So first of all, you remember probability of an event. Probability of an event is nothing but in one way you can understand required. This formula you always remember, required by total. This is very, very important formula for the probability required. That means which particular event, what exactly it is required. So first we have to write required by total. Now, there are total 3 red balls. So number of favorable outcome is 3 and number of total possible outcome, and there are total 3 plus 5, 8. So 3 by 8 is the probability of getting the red balls, and not red means 1 minus 3 by 8, that is 5 by 8. This is the probability of not getting the red. 1 minus probability of not getting the red. Box contains 5 red marble, 8 white marble, and 4 green marbles. 1 marble is taken out of the box at random. What is the probability that the marble taken out will be red? So how many total, first of all, in this scenario, first we have to write number of getting the red marbles. So number of favorable outcome in the exam, we can write like this. Number of favorable outcomes for the red marbles divided by total marbles. So this is total marbles is 5 plus 8 plus 4. So this we have to calculate and find out the, so red marbles, white marbles, and not green marbles. So this is the probability of getting red marbles, 5 by 17. Probability of getting white marbles, total marbles of 8 white marbles, so 8 by 17. Now not green means, first of all, we have to find out for the green. So for the green, it is coming 4 by 17. So not green means 1 minus 4 by 17, that is 13 by 17. This is the probability of getting all the marbles. A piggy bank contains 150 paise coins. 150 paise coins. So it is given number of 50 paise coins is 100. This is the number. 50 rupees, 1 rupees coin, 50. This is the counting, and 1 rupees coin. 1 rupees coin is 50. 20, 2 rupees coin. 2 rupees coin is 20. If it is equally likely that one of the coins will fall out when the bank is turned upside down, what is the probability that the coin 50 paise coin, what is the probability of 50 paise coins? So first of all, we have to calculate total number of coins. So 100 plus 50 plus 20 plus 10, that is 180 is total number of coins, correct? So it is divided in this part. So this hierarchy is shown. So for the 50 paise coins, so what we have to do, number of total 50 paise coins divided by total number of coins, that is nothing but this is total 100. 50 paise coins is 100 divided by 180. This will give 5 by 9. Now, next is will not be 5 rupees coin. In this 5 rupees coin is not there. So there are two ways we can find out. First way is, first of all, total number of coins minus 5 rupees coin is 10. Just we have to subtract. So it is nothing but 170. So the probability of that coins will not be 5 rupees coin. So 170 by 8. 180, that is 17 by 18. Another way is also there, that straightforward probability of getting a 5 rupees coin, number of favorable outcome divided by total number of outcome. This is 5 rupees coin. Probability of 5 rupees coin is 1 by 18, and probability of not getting 5 rupees coin is 1 minus 1 by 18 is 17 by 18. So in this, any way you can select and you can solve the problem. Gopi buys a fish from shop for his aquarium. The shopkeeper takes out one fish at random from a tank containing 5 male fish and 8 female fish. So total number of fish are 13. This is the total number of fish in the tank. In this tank, total number of fishes are 13. Now we have to find out what is the male fish probability. So probability of taking out the male fish is, total number of male fish is 5. So 5 by 13. This is the total number of probability of taking out male fish. Now, question number 12. A game of chance consists of spinning an arrow which comes to rest pointing to one of the number 1, 2, 3, 4, 5, 6, 7, 8. And these are equally likely outcome. What is the probability that it will be 8? So out of 1, 2, 3, 4, 5, 6, 7, 8, probability of getting 8, that is number of favorable outcome is, this is only one time, so 1, and total is 8, so 1 by 8. A number greater than 2, so number greater than 2 is 2. A number greater than 2, 3, 4, 5, 6, 7, 8. So total number of, sorry, second is an odd number. Odd number is 4 odd number, 1, 3, 5, 7. So 4 odd number, 4 divided by 8. This is the probability of getting an odd number. Odd number is 4 by 8. So number of favorable divided by total, favorable by total. Always remember favorable by total or required by total. So this is the probability of getting odd number. Third is a number greater than 2. Number greater than 2 is 3, 4, 5, 6, 7, 8. So which is total is 6. So 6 by 8 is the probability. And fourth question is a number less than 9. So 8 number less than 9. All numbers are less than 9. So in this case, the probability is 1. So 1, 2, 3, 4, 5, 6, 7, 8. All numbers are less than 1. So this is the probability 1 by 8. So in this way, you can solve this type of problem. A die is thrown once. Find the probability of getting a prime number. So once we throw a die, in that case, total number of sample space is 1, 2, 3, 4, 5, 6. This is the total possible outcome. A prime number. So in this prime number is, in this case, prime number is 2, 3, and 5. So the probability of getting the prime number is 3. So 3 by 6. A number lying between 2 and 6. A number lying between 2 and 6 is 3, 4, 6, 3, 4, and 5. So this is the probability 3 by 6 is 1 by 2. And third is an odd number. So in this case, whatever the odd number, that is only 1, 3, and 5. So in the counting, total 3. So 3 by 6. In this way, we can find out the probability. Now, question number 14. One card is drawn from a well shuffled deck of 52 cards. Find the probability of getting a king of red card, king of red color. So event of getting a king of red color, this we have to find out. And we know there are 4 kings in a deck of playing cards, out of which 2 are red and 2 are black. So probability of getting a king of red color is 2 by 52. Second event is face card. Event of getting a face card is, there are total 12 face card, in which 4 king, 4 jack, and 4 queens. So total face card is probability of E2 equal to 12 by 52, that is 3 by 13. Now, third question, total number of red face card. So total number of red face card is, out of 12, 6 are red. So 6 by 52, that is 3 by 26. 4, event of getting a jack of heart. So total number of count of jack of heart is 1. So there are 4 jack cards in a deck, namely 1 of heart, 1 club, 1 spade, 1 diamond. So probability of getting jack of heart is 1 by 52. And fifth, event of getting a spade. Number of, so in a deck of cards, there are 13 spades, 13 club, 13 heart, and 13 diamonds. So number of favorable spades is 13 by 52, that is 1 by 4. Number of queen of diamond. So there is only 1 queen of diamond. Number of favorable case 1, that is only 1. So 1 by 52. So in this way, all the problem you can solve. Question number 15. 5 card, the 10, jack, queen, king, and ace of diamond are well shuffled with their face downwards. 1 card is then picked up randomly. What is the probability that the card is queen? So total number of cards, if you will see, then 1 is 10, Jack second, Queen, King, and Ace. So 1, 2, 3, 4, 5. So total number of card is 5. What is the probability of getting the queen? So only one queen is there, so probability is 1 by 5. If the queen is drawn and put aside, what is the probability that the second card picked up is an ace? So once we will take the queen and after that we will remove from the total sample space, then number of second card picked is ace, is that is 1 by 4 because total outcome is 4 only. Now third, a second card picked up this queen. Now there is no queen, so 0 by 4, that is 0. Now, question number 16, we are going to see 12 defective pens are accidentally mixed with 132 goods one. So first of all, once we have to check 12 defective and 132 good. So both are mixing, so this will give the total sample space. So total number of pens, 12 defective, 132, so 144 pens. It is not possible to just look at a pen and tell whether it or not it is defective. One pen is taken out at random from this lot. Determine the probability that the pen taken out is a good pen. Now there are total 132 pens which is good and total sample space is 144. So 132 by 144, that is 11 by 12 is the total probability of taking pen which is good condition. 17. A lot of 20 bulbs contains 4 defective ones. One bulb is drawn at random from a lot. What is the probability that this bulb is defective? So total number of bulb is 20. Number of possible outcome is nothing but the 20. Now we have to find out how many bulbs which are defective. So number of outcome favorable to E, that is 4 bulbs are in this, only 4 bulbs are defective. So 4 bulbs are defective. So we want to find out the probability of defective bulbs and 4 are defective. So 4 divided by 20, it will give the probability of defective bulbs. Second, suppose what is the probability? This is the first part. Second part, suppose the bulb is drawn, is not defective and not replaced. Now one bulb is drawn at random from the rest. What is the probability the bulb is not defective? Now in this case, total number of bulb is 20. So one good bulb is drawn and put outside. So out of 20, one bulb we take out. So that there are total 19 bulbs which are now we have. Out of that, 4 are defective. 4 are defective. So out of 4, if it is defective, then total 15 are correct. So 15 good bulbs and 4 defective bulbs remain in a lot. Now total number of bulbs is 19. So number of outcome favorable to E1 is 15 by 19. So in this way we can find out through the tree method. Now question number 18. A box contains 19 discs which are numbered from 1 to 90. One disc is drawn at random from the box. Find the probability that it bears 2-digit number. Now total number of discs in a box is 90. So total, this is the sample space. Now we have to find a 2-digit number. So event of getting a 2-digit number is if you will calculate 10, 11, 12 up to 90. So there are total number of event even is nothing but the 81. So probability of getting disc bearing 2-digit number is 81 by 90, that is 9 by 10. A perfect square. Event of getting a disc perfect square, that is perfect square is 149. This is the perfect square. So number of favorable outcome E2 is 9. So 9 by 90, that is 1 by 10. Third, Event of getting a disk bearing a number divisible by 5. So 5, 10, up to 90. This is the divisible number, which is total counting is 18. So 18 by 90 is 1 by 5. Question number 19. A child has a die whose 6 faces shown in the letter as given below. A, B, C, D, E, A. Die is thrown once. What is the probability of getting a A? There are 2 A are there, so 2 by 6. So event, first we have to write what we have to find, event of getting a letter A. So there are total number of the event in the favor of 2 is A and A. There are two numbers. So 2 is there. Probability of getting letter A, 2 by 6 is 1 by 3. Now, second question is probability of getting a D. There is only one D. So 1 by 6. Correct. So event of getting a letter D. So number of favorable outcome for the E2 that we have to find out, that is 1 by 6. Now, suppose you drop a die at random on the rectangular region. What is the probability that it will land inside the circle with diameter 1 meter? Now, first of all, this is a rectangle. So this is the probability. First of all, we have to find out the area of rectangle, that is 3 into 2 equal to 6 meter square. Now, area of circle and diameter is given 1. So radius is 1 by 2. This is 1 by 2. Pi r square. This is pi by 4 meter square. This is the area of the circle. So probability of getting a die land inside the circle, that is pi by 4 divided by 6, pi by 24. Question number 21. A lot consists 144 ball pen, of which 120 are defective and other are good. Noori will buy a pen if it is good, but will not buy if it is defective. The shopkeeper draws one pen at random and gives to her. What is the probability that she will buy it? What is the probability that she will buy it? And second, she will not buy it. So, when the Noori will buy, only when event of getting a good pen only, this is the first case. So, total number of pens are 144. Number of outcome favorable to E, that is total number of ball pens minus defective, that is 124. And probability of getting a buy of good pen is 124 by 144, and it will give 31 by 36. She will not buy it. So buying probability plus not buying probability is always 1. So 1 minus probability of getting the good pen, that is 5 by 36. So we have to use this formula. 22. 2 dice, one blue and one gray, are thrown at the same time. Event sum on 2 dice is given this probability. A student argued that there are 11 possible outcome of 2 to 11, 2, 3, 4 up to 11. Therefore, each of them has probability 1 by 11. Do you agree with this argument? So total possible outcome on throwing 2 dice, first of all, we have to find out this. So this is the total possible outcome. And how we are finding out? This is very easy. 1, 2, 3, 4, 5, 6. And here 1, 2, 3, 4, 5, 6. 2 times. So 1 you have to keep in the horizontal, 1 you keep in the vertical. After that you have to make 1, 1, 1, 2, 1, 3, 1, 4, 1, 5, 1, 6. After that 2, 1, 2, 2, 2, 3, 2, 4, 2, 5, 2, 6 up to 6, 1, 2, 6, 6. So total number of sample space is 36. Now sum on 2 dice is 3. E1 should be, this is from here, just we have to select which is the number which is giving sum of the 2 dice is 3. So 1, 2 and 2, 1. So this is total 2 event is coming like that. 1, 2 and 2, 1. So this is total number of favorable outcome is 2. So 2 by 36, this is 1 by 18. Similarly, sum on 2 dice is 4. This is the possible outcome 1, 3, 2, 2 and 3, 1. So 1 by 12. Same way 5, we have to select 1, 4, 2, 3, 3, 2 and 4, 1. This is the favorable 4 by 36. 6, This is the number which is 5 outcome is possible. 1, 5, 2, 5, 1. And this is 5. So 5 by 36. Similarly, for the 7, we have to write 1, 6, 2, 5, 3, 4. So this is total number of available is 6. So 6 by 36 is 1 by 6. 7. Sum on 2 dice is 9. So 2 dice is 9 is we can write 3, 6, 4, 5, 5, 4, 6, 3. This is 1 by 9. 10 for the 10 we can check 4, 6, 5, 5 and 6, 4. So this is the probability 3 by 36, 1 by 12. And sum on the 2 dice is 11. So 6, 5 and 5, 6. So this is the event 2, 2 by 18. Now, whatever the second question, we do not agree with the given argument because the event of 11 sums are not equally likely. So whatever the probability we got for every number, that is different. So it is not equally likely. Now, a game consists of tossing 1 rupees coin 3 times and noting its outcome each time. Now, how to find out the total sample space? Just you see, one time when we throw a coin, so we will get HT, and 2 times for the probability, we will get HH, HT, after that TH, TT. Again, this suppose we have to write in the vertical, and now after that, this is H and T. Suppose this is the value and this is in the horizontal again. So total sample space is HHH, HHT, HTH, HTT. So this is the thing, THH, THT, TTH, TTT. So this is the total outcome is 8. Now this is the first step is total, find out the total sample space. Now Hanif wins if all the tosses given in the same result, 3 heads or 3 tails, and lose otherwise. Calculate the probability that Hanif will lose the game. Now, E be the event that Hanif will lose the game. Hanif will lose the game if all the tosses do not have the same result. So this is the probability. In this outcome, this is not the same result. That is 6 outcome in which the same result is not coming. So total 6 by 8. This is the probability of losing the game. And if he's not losing, this is the probability of losing the game. And if lose the game, this is the probability, because in this outcome is not the same. 24, a die is thrown twice. What is the probability of? So total sample space is 36. That already we saw 1, 2, 3, 4, 5, 6, and 1, 2, 3, 4, 5, 6. In this way, we can find out the total sample space, that is 36. 5 will not come up either time. So 5 will not come up either time. We can write 1 minus probability of E, that is total sample space is 36. 5 will not come up either time. 2 times it will not come. So in this, if we will calculate, then we can find out. So 11 times it is not. So probability of not is nothing but 1 minus. So how many times it is coming? 11 times 11 by 36. Just you can count. 5 will come up at least once. So once from the sample space, this is the only one time it is coming, that is 11. So 11 by 36. So first of all, this is the 5 it is coming, that is 11 by 6. 5 it is not coming, that is 1 minus 11 by 6. So first of all, focus on this second part, then automatically this will. So this event is the 5 coming, and in this 5 is not coming. Now last question, which of the following argument are correct and which is not correct? Give reason. If 2 coins and are tossed simultaneously, there are 3 possible outcomes: 2 head, 2 tail, and 1 or 1 of each. Therefore, for each of these outcomes, the probability is 1 by 3. This is the first. Now, this is incorrect. We can classify the outcome like this big, but they are not then equally likely. A reason is that one of each can result in two ways, from a head on first coin and tail on the second coin, or from a tail on the first coin and head on the second coin. This makes it tricky as likely as two heads or two tails. So this is incorrect. And second is, now second question is, if the die is thrown, there are two possible outcomes, odd number or even number. Probability of getting an odd number is 1/2. That we have to see. Now, probability of getting an odd number is, now there are 1, 2, 3, 4, 5, 6. So there are 1, 2, 3, 4, 5, 6. So there are 3 odd number, 3 even number. So for the odd number, probability is 1/2, and for the even number 1/2. So this statement is correct. So in this way, we can find out the probability. So I hope this chapter is crystal clear for all of you. Just you do the revision and make practice. Thank you.